Welcome to part 2 of Red Hat in the Cloud Ansible. I am Magnus Glans, a solution architect at Red Hat, who will be your guide through this part of the journey. Now, to reiterate for some of you, the Red Hat portfolio is organized into 3 pillars, providing a complete solution for our customers' cloud journeys. The first pillar focuses on hybrid cloud infrastructure, and this is the foundation, a seamless stack across all your footprints. The second pillar, management and automation, is what we will focus on in this presentation. It is about opinionated automation tools that simplifies management of hybrid environments. Finally, the third pillar is dedicated to cloud-native development. These pillars emphasizes the importance of having a consistent technology stack. Now, Ansible Automation Platform is the Red Hat product for customers who wants a supported enterprise experience for their Ansible automation.
Now, if you're considering that Ansible might look like the One Ring, stop for a moment and think. So, consider this. You get the greatest value from automation when you are automating things that are not already automated. So start there, before you go ahead and try to forge the One Ring that rules all automation. Now, with that said, Ansible has made a name for itself by being a platform that can manage automation in all situations. Automate all things used to be the original Ansible saying. And Ansible can really provide 100% coverage for any ambitious automation strategy. You no longer have to consider, do we have coverage for this? Can we automate this system with Ansible? The answer is yes. Now, Ansible can orchestrate complex workflows across any manner of infrastructure, public clouds. You can stitch together security and databases and application front ends, anything that you have in your technical stack. And consider also that not everything is cloud provisioning and cloud decommissioning. When it comes to technical domains like security or ITSM or storage, you cannot just destroy and recreate that. You need some day 2 operational tasks as well. Now, you can use Ansible Automation Platform anywhere you like. And if you have already committed to spending something with a public cloud provider, you can reuse that for Ansible. Now, Ansible has been made famous by its rich ecosystem. There are hundreds of thousands of automation patterns available for download on the internet. And now we're proud to present that there is also certified content. So as an Ansible Automation Platform customer, you get access to certified and secure content straight from us and straight from our partners. With that said, enough slides, it's time for some demonstrations.
Now, we're going to demonstrate consistency using Red Hat Ansible Automation Platform. How you can have automation that looks and feels exactly the same across data center, into public cloud, in hybrid setups, or in multi-cloud setups where you're consuming several different public cloud providers. We'll start by logging in. What you are looking at here is the login page of Red Hat Ansible Automation Platform. Obviously, this is the main page. And here we can see status of all the automation that so far has been running in this setup. Now, it's all been successful so far. Let's see how this demo goes. We'll go to the templates view. Here we have an overview of all the distinct pieces of automation that has been created by us for this demo. And it's a good mix of day 1 and day 2 tasks. Day 1 tasks, classical like create infrastructure, create virtual machines, destroy them and such. And then we have day 2 tasks like help automate onboarding of new help desk task staff by creating a user in Active Directory and configuring it properly, or doing patch management for Linux systems, etc. You all know that the limits of Ansible automation, well, you can use it to automate all things. Now, I'm not going to show you all the features of the platform because we don't have time for that. So if there is something you're missing, recommend go onto YouTube or go to ansible.com and have a look around. This platform is extremely capable. But I'm going to focus on features related to consistency across hybrid and multi-cloud deployment patterns. Now, let's start by just firing off a piece of automation. We'll run the patch management one, and the author of this automation now has allowed me to choose whether I run this piece of automation, doing a check to see kind of what happens, if it would update a system or not, or actually do the patch management. We're going to run it because it's more fun like that. So we'll select, I'm being allowed to select the system to patch here as well. And we'll just launch this. Good. Now, it's waiting for job output at this point, and it says pending. So let's see what's going on. We'll go to the job queue and see what it's currently working on. And we can see that that is inventory sync. Right. So an inventory, you know what that is? That is the collection of things that you run automation against. And when we are talking about public cloud specifically, the thing is that we're creating and destroying systems more commonly. So we want to be sure that this system that I told the platform to patch now, we want to know if that system exists at all. So that was what was being done. And if I show you this inventory, I actually created this inventory that syncs against multiple public clouds. So both AWS and Azure. So it's fetching things that are created in both those clouds and then putting that into a single inventory and dynamically doing this. So here's all the systems that's been created so far, and here's groups where those systems have been put into. So these dynamic inventory scripts that you can attach to an inventory and get this automatic fetching of information, they can also automatically create groups for you. So you can use tags, for example, in these public clouds, and that will automatically assign systems to various, arbitrary groups that you decide on. So here we have all the Amazon systems in a group, and here we have the Linux systems on Azure in a group. But yeah, there could be any type of group that would make sense for you. So let's go back to the actual patch management job that was run, and it's completed successfully. Happy to see that. And here we can just scroll through the output of the patch management playbook, and we can see it's doing a bunch of different things. It's scanning packages and services and running an upgrade of the software. Then after it's been that's been done, it does a check to see if we actually have to reboot the system or not. And here it says that no, that's not necessary. So it skips the reboot task, goes on to create a patch management report of the system. Good. This is all information that's logged. And if I go into detail, this is even more information that's logged for each piece of automation running. This is something we can send to a central location. And to have observability that stretches across multiple platforms, that's not something that we necessarily provide, observability platforms, but you can be sure that our platform integrates to all of those. So you can send the information now off to a central location. You could hear someone coughing. That's because this is recorded from a sofa at home. Now, we can see who launched the piece of automation. We can see revision number. That's interesting. What's revision number? Well, that actually refers to version control. So automation, that's development. And when we're doing development, we need version control. It's considered a basic hygiene factor. Now, if we drill into what's called a project in the platform, that's how we attach to version control systems, where we can connect to a repository in version control. Could be a specific branch or even a specific commit that we're connecting to. But this is one of the first key things done when it comes to consistency, which is that to have a single source of truth for the actual automation that our staff is writing for our IT landscape. That is very important. And if we jump into the version control system, I'll just show you a playbook out of this. Is a playbook that creates a virtual machine in AWS. And if you're not familiar with a playbook, These things here, where it says of the name, that's modules. That's the things that does the heavy lifting in Ansible. So here we have, for example, a task that creates an EC2 instance. That's a virtual machine in Amazon, and it uses the EC2 instance module to accomplish that. And then it has some arguments and executes. Those modules, in this case, they're fetched from a collection. Collection is a gathering of modules, and I want to show you where that collection comes from. So I'll just take us to the main collection page, and we're now on console.redhat.com, where we have the online version of Automation Hub. So Automation Hub is where we keep our certified ecosystem of collections and modules. So many different companies have written automation for Ansible, and that's provided, certified, and then provided to the customers of Ansible Automation Platform. So Automation Hub is included in the platform. You don't pay extra for that. You can run the Automation Hub locally within your private networks without having any connection to the internet as well. But you can see here that there are small green check marks as we scroll through different things here. And that means that it's been cryptographically signed, this collection. So for example, here we have automation modules for iOS provided by Cisco. And supply chain security is not only a thing for when you're developing applications, that's also a thing when you're developing automation. Think about it. It's the same, right? You're defining dependencies, you're pulling things from the internet, and that can be a scary thing when you're creating an application and you don't exactly know what code you're pulling in. It's the same when you're doing automation. You should care about the code that you run in your networks. And then Automation Hub is a way that you can, resolve that concern. Also, by using Automation Hub, you can have a single place where you version control all these toolboxes when you're running your automation. So you can have consistency across multiple Ansible Automation Platform setups across multiple different clouds, private data centers, and so on and so on. Now, I was using the Amazon collection there in that playbook, and here we can see that there is an Amazon collection provided by Amazon to us, right, and signed. And if we look at GCP, for example, Google Cloud, Google has provided a large number of different modules and roles and plugins and such for automating against Google Cloud. And if we're typing in Azure here, we find the Azure collection provided by Microsoft and a large number of modules to automate against Microsoft Azure. Now, if we dig into one of these collections here, we can see the actual content of the many different modules provided. So here's the Amazon modules, for example, that you then use to do your automation. So for example, if you want to manage your IAM users in Azure, you can use the IAM user module provided by Amazon. And here's the documentation for that module, the input, the various options that you have for the module. And if you scroll to the bottom here, you will always find an example section. And I think this is neat. You just copy and paste, these examples into your playbook to kind of know how it should look like or could look like. It's very neat. All right. Now, there's another thing that I want us to look at. If we return to this, patch management job actually, and go into details, we see this execution environment, it says. And that's another thing that provides consistency. So when this playbook here, patching YAML, is this exact version of that playbook from version control is being executed in this platform, then the big question is, will this piece of automation actually work? So our solution to ensure that is always the case is using execution environment. So execution environment is a container. So if you're not familiar with what a container is, it's basically a zip file that contains dependencies for the thing that you want to run. So in our case, that is, Ansible core, Ansible playbook, command, Ansible version of Python and dependencies that that various core modules does have. And we can go into the different execution environments here. These are mainly the ones that's out of the box from Red Hat, but you can build your own execution environments. And the neat thing with that is that then you really get, lifecycle management control over your automation. Just as when we're talking about development, lifecycle management is a major concern when it comes to creating automation. How do you ensure that your automation that you're building your company on is going to work in 5 years or even 2 years? So execution environment allows you to detach the lifecycle of the platform itself. Ansible Automation Platform is going to be updated by some central team, perhaps. And then you don't want to come in on Monday and find that they did an upgrade and your automation is no longer working, right? Especially when you're automating important things. So execution environments is the solution to that. You take control over the exact environment that runs your automation. And that is lifecycle done by whoever owns the automation then. You can obviously use general purpose execution environments, but yeah. So that is really neat. And containers, they are distributed using registries, and you can have a central registry, again, distributing, having consistency, across all your various footprints. Really neat. Okay, let's go back to the list of various distinct pieces of automation that's published in this installation. I want to show you another thing, which is how you can stitch automation together, and showcasing how we can deploy across multiple clouds. So you can already see that we have some pieces of automation here that creates infrastructure, creates virtual machines for various public clouds. And there are many ways that you can stitch automation together using Ansible. Roles collections are two of those, and workflow job templates is another one that I'm going to show you now by executing this piece of automation right here, which is a workflow job template. And you can see that it now fires off one piece of automation that's called Create Infra AWS, and that puts in place the necessary infrastructure prerequisites to deploy things in AWS. And I'm going to show you what kind of stuff that is, but you can imagine networking and security and stuff like that. And then we have the same for Azure here. And once those things have run, we're going to go ahead and deploy a bunch of virtual machines in those two public clouds. So we have one Ansible Automation Platform cluster, and we're managing, multiple, doing a complex deployment that requires resources deployed in multiple places here. Some virtual machines in Azure and some of them in AWS. So now the first step has executed here, and we can see that we're creating a VPC, internet gateway, some security group, subnet for our network, some routing, etc. in AWS here. And we're doing the same thing then in Azure. So if we look behind the hood, this is the Amazon AWS console. And if we go to the EC2 dashboard, that's where we can see a lot of things that we have deployed. Here we can see, for example, instances that we have executed and fired off here. We can go to security groups here. We can see, so security groups is one way that you can create firewall rules in public cloud. Here we can drill into the specific security group and see what kind of firewall rules were created. And VPC, that's the virtual private network, basically, that we're doing our deployment on. And here's Azure. And if we go into our resource group, so that's a bucket where we can put various things in, manage our resources in a good way. And here we can see, here's also a security group created. So here's the firewall rules that we have in the Azure deployment. And here we have an overview of what's allowed and not allowed in this set of rules. Now, if we go back to the executing workflow, we can see that it's already ahead and ensuring that virtual machines are in place. And we have some Windows machines here, 3 Windows servers spread across Azure and AWS. And then we have a number of Linux machines also spread across the two public cloud providers. And once we are done with creating those, we are taking the Windows and Linux machines that's on AWS, and we're patching them to a specific patch level. And once that's done, we're deploying an actual artifact. So in the case of Linux, we're deploying a container using Podman, and on Windows is a web application deployed on Microsoft IIS web server. Now, you can recognize this. This is, continuous deployment. This is the CD part of CI/CD. So imagine that you have a CI engine and it's creating your artifacts. And once you get to the continuous deployment part of the story, it's really nice to be able to use a platform like Ansible Automation Platform, as that is so full featured and so many plugins and ready integrations to the public cloud world, or any footprint where you might want to deploy to. And obviously then you wouldn't have an integration, wouldn't be a human being clicking on a web page. Then you would use something like a REST API. So this is the REST API for Ansible Automation Platform. Here you can reach all of the things of the platform. And there's also a CLI that you can use easily, just put into a CI pipeline script to fire off the automation that you require, making life a bit easier for your development teams. So while we're waiting for the Windows systems on AWS here to patch, well, you can see if this was like a competition, a race or something, I guess Linux won. It's a bit faster. But if we kind of conclude the important things that we have been seeing now, so consistency is brought to you by the following things. One, you can install the platform itself anywhere you like. Anywhere that you can run Red Hat Enterprise Linux, you can deploy this. So that's everywhere from edge case scenarios, private data centers, hosted solutions, public clouds. You can run this across multiple public clouds. And the automation itself, you can have consistency by having a central version control system, or a central version control truth, at least. And then the platforms, they just consume, what should the automation be looking like. Number two, the tools that you are referencing in your playbook, they can be fetched from Ansible Automation Hub. So hosted by us or hosted by you, you choose. And so you can control the different versions, what specific versions of the tools are you going to be using. And then finally, you have the execution environment, so you remember. So when the actual automation is executing, it just is in a controlled manner, and the environments looks the same all the time, and you can have the same experience across all the different footprints that you have. And when you do that, well, then it looks like this: 305 successful pieces of automation running there, 173 successful automation jobs there, not one failure. And that's the power of consistency.
And with that, we are at the end of the session. Thank you everyone for tuning in, and enjoy the rest of your day.
Red Hat and Intel enjoy a strong partnership that spans more than 2 decades. At the heart of this collaboration is our common focus on hybrid and multi-cloud infrastructure as the foundational building blocks for your digital transformation. Intel is not just a silicon company. We are the #1 contributor to the Linux kernel, and we have over 20,000 software engineers working with partners like Red Hat to optimize software on our architecture. Together, Red Hat and Intel help customers to navigate digital transformation with solutions that provide more choice, flexibility, and innovation. Red Hat and Intel have a long track record of delivering joint market-ready solutions to many industries and enterprises. Red Hat and Intel are the beating heart of the open source ecosystem. Our joint solutions are built on open platforms with enterprise-grade open source software and x86 architecture from edge to cloud. Red Hat and Intel solutions are supported by a strong ecosystem and are tested and validated before being certified or deployed in the Red Hat market space. Our engineers continuously work to harden our platform and solutions with industry standards and enterprise-grade security. Open source and x86 offer you an open platform for innovation with choice and the agility to deploy quickly. We just launched the 4th Gen Xeon processors, delivering to customers a range of features for managing power and performance, making the optimal use of CPU resources to help achieve their sustainability goals. Unlike any other data center processors on the market, and already in the hands of customers today, the 4th Gen Xeon family greatly expands on Intel purpose-built workloads, first strategy and approach. Today, there are over 100 million Xeons installed in the market, from on-prem servers running IT services, including new as-a-service business models, to networking equipment, managing internet traffic, to wireless base stations, computing at the edge, to cloud services. Thank you for your time. We look forward to collaborating with you to enrich your digital transformation journey with Red Hat and Intel solutions.